Hello everyone, this is T. Shivapriya, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women. In this video, we are going to discuss about solar pond. We will see about the introduction of solar energy, solar pond and its working principle, types of solar ponds and its efficiency, advantages and applications. Introduction of solar energy. We know that the sun is the largest source of renewable energy, and this energy is abundantly available in all the parts of the earth. It is in fact one of the best alternatives to the non-renewable source of energy. Solar energy has been used since prehistoric times, but in a most primitive manner. Before 1970, some research and development was carried out in a few countries to exploit solar energy more efficiently, but most of this work remained mainly academic. The application of solar energy which are enjoying most success today are solar water heating, solar drying of agricultural animal products, solar cookers, solar engines for water pumping, solar furnace, solar photovoltaic cell, solar electric power generation by solar ponds, steam generators, etc. On way to tap solar energy is through the use of solar ponds. Solar ponds are very large scale energy collectors with integral heat storage for supplying thermal energy. It can be used for various applications such as process heating, water desalination, refrigeration, drying and powder generation. Generally, pond is defined by a body of collected water usually smaller than a lake. Here, a solar pond is a body of water that collects and stores solar energy. Water warmed by the sun expands and rises as it becomes less dense. Once it reaches the surface, the water loses its heat to the air through convection or evaporates, taking heat with it. The colder water, which is heavier, moves down to replace the warm water, creating a natural convective circulation that mixes the water and dissipates the heat. The design of solar ponds reduces either convection or evaporation in order to store the heat collected by the pond. A solar pond can store heat much more efficiently than the body of water of same size because the salinity prevents the conventional current. The simplest solar pond is a very shallow, about 5 to 10 centimeter deep with the radiation absorbing. A bed of insulating material under the pond minimizes loss of heat to the ground. The working principle of solar pond. The solar pond normally consists of the following three zones: upper convective zone, lower convective zone, and intermediate gradient zone. First, we see about upper convective zone. Upper convective zone is the adjacent to the surface. There is a homogeneous convective zone that serves as a buffer zone between the environmental fluctuation at the surface and conduct heat transport from the layer below. Intermediate gradient zone. A gradient which serves as the non-convective zone, which is thicker and occupies more than half the depth of the pond. The salt concentration and temperature increases with the depth. Finally, lower convective zone. This is the highest salt concentration zone and where the high temperature are built up almost as thick as the middle non-convective zone. There are two types of solar ponds. Number one, convecting solar ponds and non-convecting solar ponds. Convecting solar ponds. It consists of the bag as a blackened bottom as foam insulation below and two types of glazing on top. The sun heats the water in the bag during the day. At night, the hot water is pumped into a large heat storage tank to minimize heat loss. Excessive heat loss when pumping the hot water to the storage tank has limited the development of shallow solar ponds. Non-convecting solar ponds. The main types of non-convecting ponds is a salt gradient ponds. A salt gradient pond has three distinct layers of brine of varying concentration because the density of the brine increases with the salt concentration. The most concentrated layer forms at the bottom. The least concentrated layer is at the surface. The salt commonly used are sodium chloride and magnesium chloride. A dark colored material, usually betel rubber, lines the pond. As sunlight enters the pond, the water and the lining absorb the solar radiation. As a result, the water near the bottom of the pond becomes warm up to 93.3 degrees Celsius. Even when it becomes warm, the bottom layer remains denser than the upper layer. Pumping the brine through the external heat exchanger or an evaporator removes the heat from this bottom layer. Another method of heat removal is to extract heat with the heat transfer fluid as it's pumped through a heat exchanger placed on the bottom of the pond. This is the flow diagram of solar pond electric power plant. The thermal energy from solar pond is used to drive a Rankine cycle heat engine. Hot water from the bottom level of the pond is pumped to the evaporator, where the organic working fluid to vaporized. The vapor flows under high pressure to the turbine and thereby expanding through the turbine wheel and the electric generator. The vapor then travels to the condenser, where cold water from the cooling tower condenses the vapor back into a liquid. The liquid is pumped back to the evaporator where the cycle is repeated. The advantages of solar pond: it is environment friendly energy and it has no pollution. It is a renewable energy sources. It can be used for many purposes such as generation of electricity, heating of fluids, etc. No need of a separate collector for this thermal storage system, and it has a low maintenance cost. Thank you for watching.